Okay guys, welcome to the first video of graphical trig. This is going to go through the lesson 1 material, which is right triangle trig, reciprocal trig ratios, special triangles, and radian measure. So a couple of these pages I'm just going to skip because they're more related to lesson 2 stuff, but I hope this is helpful. And if you have any questions, just put them up in the shared Google Docs that we'll create for your classes, and you guys can answer each other, and your teacher will be looking to see if there are any questions that are unanswered by the class, and we will get those answers to you. So let's get started. So the first thing here to point out are these three trig functions: sine, cosine, and tangent. Okay? So since they're functions, they have an input and an output. The input is always going to be an angle, and the output is actually a ratio of sides. Okay, now when I highlight this, it's really important to remember that there are a ratio of sides in a right-angled triangle. Okay? We're going to look later at what happens if we have a non-90 degree or a non-right angle triangle, but for these, it's just triangles that have a right angle in them. All right? So if we have a right triangle, then we basically have two angles. In this case, there's an angle here and there's an angle here that are not right, that are not 90 degrees. We're going to pick one of them. In this picture, it's this top left one. Okay, relative to this angle, there are three sides. There's the opposite side. It's across from that angle. And there's actually two sides touching the angle. Okay, this side here is the hypotenuse. It's the one opposite the 90-degree angle. The side that touches this angle, that isn't the hypotenuse, is the adjacent side. Okay, so we've got these three sides. Based on this angle, here's my opposite, here's my adjacent, here's my hypotenuse. Okay? So sine, cosine, and tangent are defined by these three ratios respectively, right? And there's this mnemonic, SOHCAHTOA. It's a good way to remember what sine and cosine and tangent are. So literally, it says that sine is equal to the opposite over the hypotenuse side, right here. The ka part of the ka part of SOHCAHTOA, that says that cosine is equal to the adjacent over the hypotenuse. And then the toa part, that says that tangent is equal to the opposite over adjacent. All right? So these are just definitions that you have to know. Nothing really crazy to talk about with that. They're just defined functions, really. All right, so how do we apply this? Well, here we've got an example, right? We've got our right triangle because there's a 90-degree angle here. And we've got an angle S, an angle T, and an angle R. Three ratios to come up with. So let me pause. See if you can compute these three values on your own, and once you've done that, you can start playing the video again and seeing if you're getting the right answer. Okay, we're back. So the way I'm going to do this, sine of S. Well, here is my angle S. Sine is equal to opposite over hypotenuse, so the sine of S in this case is equal to 6 over 3 root 5. All right, if I want to rewrite that, that's the same as 2 over root 5, which is the same thing as 2 root 5 over 5. Okay, but this step and this step are just, that's not really trig. This is the trig part of it, is writing this ratio. For cosine of t, well, t is here. Cosine is adjacent over hypotenuse. Look what happens. The same exact thing. So it's equal to 6 over 3 root 5, which is 2 root 5 over 2. Last one, tan of S. Well, S again is right here. So if I want the tangent of S, I'm going to take the opposite over the adjacent. So the tan of S is equal to 6 over 3, which is 2. Done. Easy. Okay. Next page. Some more definitions. So we have, and we've talked about sine, cosine, and tangent. There's 3 more trig functions that we're going to discuss. All right. First is cosecant. Cosecant is defined as hypotenuse over opposite. So another way to think about this is actually 1 over opposite over hypotenuse, which is 1 over sine theta. All right. Secant, that's hypotenuse over adjacent. Well, that's 1 over adjacent over hypotenuse, which is the same thing as 1 over cosine theta. All right, and surprise, surprise, the next one's cotangent. This is equal to 1 over opposite over adjacent, which is equal to 1 over tan theta. Okay? So we've got these 3 trig functions plus the ones covered on the previous page. All right? It's a little bit confusing, but basically one way to think about it is that you can say sine goes to cosecant, so S goes to C, cosine goes to secant, C goes to S. Okay, so cosecant and cosine are not related. Well, they are related, but not in a way that we really care about. And sine and secant are not related. All right. This example here, which says evaluate the trig the trig ratios for the angle A. Well, this is a kind of a tough problem because first of all, we don't know what angle A is. All right, so let's put an angle A in here. Got my 90 degree, and let's call these 2, 7, and B. All right, so we've got an angle and 3 side lengths. Question is, find the 6 trig ratios for that angle. Okay, so I'm going to stop again, let you work through this, see what you get, and when you're ready to go, keep viewing the video. Okay, so if we write out the 6 trig ratios, I've got sine of A, and that's going to equal 2 over 7. All right, opposite over hypotenuse. I've got cosine of A, that's going to be the adjacent over the hypotenuse, which is B over 7. And tan of A, that is the opposite over adjacent, so that's 2 over B. All right, so I've got 3 of the 6. To get the remaining ones, I'm going to use reciprocal stuff. So cosecant of A is 1 over sine, that's 7 over 2. Another way to think about it, cosecant of A, well, that's the hypotenuse over the opposite. Here's A, there's my hypotenuse, there's my opposite. All right, but what we kind of want you guys thinking is this is cosecant, this is sine. These are reciprocally related, right? So they're multiplicative inverses of each other. Okay, secant of A. Well, that's 1 over cosine, so that's 7 over B. 7 over B. And cotan A, well, that's 1 over tan, so that's B over 2. And just to double check, cotan is adjacent over opposite. Here's A, here's my adjacent side, here's my opposite. Yeah. All right. One more question here. Find x, right? And I think, because we're not talking about inverse trig yet, let's rephrase this and say find the sine of x. A little bit of a more difficult problem. So I'll stop again, let you kind of work through this, and we'll go over the answer in a minute or so. All right, so in order to find sine of x, right, if we remember sine of x is equal to, in this case, this, which I don't know, that's a bad variable. Let's call this g. So sine of x is equal to g over 15. If I can solve for g, then I can actually get a ratio. So we've got to remember right triangles. So we know that 10 squared plus g squared is equal to 15 squared. So that means 100 plus g squared is equal to 225. G is equal to the square root of 125, which is 5 root 5, I believe. So if we come back and we want to find out what is the sine of x, well, now we can just replace g with what it's equal to, which is 5 root 5. So let's write that. So this is equal to 5 root 5 over 15, which is equal to root 5 over 3. By the way, just as a check, right? If this is the ratio of opposite over hypotenuse, this number should never be bigger than 1. If we're getting a number that's bigger than 1, something's wrong, because then we're saying that the opposite side is bigger than the hypotenuse, and that would not be good. A couple of other things, definitions, angle of elevation and angle of depression. So the key here is that the angle of depression and the angle of elevation are equal. However, we got to remember that the angle of depression is from the higher object, higher thing's perspective, and it's their angle looking down, and the angle of elevation is the lower person's perspective looking up. Okay, but these angles are the same because these are measuring distance from a parallel sight line. So might as well mark this. These lines are parallel. Okay, and that means that geometrically these angles have to be the same. One more thing on here is that solving a triangle means finding all the sides and all the angles, right? So to fully solve a triangle, you find all the side lengths and all the angles. Okay, special triangles. So you got two of these. The first one is a 45, 45, 90. Okay, the second is a 30, 60, 90. So really, it's better for us to say that these are special right triangles. All right, so you got to remember those angles, and equally as important is the ratio of the side lengths. So in the 45, 45, 90, well, we know it's an isosceles triangle, right? Because it's got two side lengths that are the same because two angles are the same. One way to think about the ratios is 1, 1, root 2. If you want to use variables, you could say if this is x, this is also x, and then the hypotenuse is x root 2. All right? In the 30, 60, 90, the ratios that we want, or that I guess hold, are 1 is the side opposite 30, root 3 is the side opposite 60, and 2 is the hypotenuse. All right? Another way to kind of write that, if we want to use variables, is this is x, this is, surprise, surprise, root 3x, and this is 2x. Okay? Again, more stuff that you have to memorize, and then we can compute all these values. All right? Geez, what am I doing here? So the sine of 30 is right here. So the sine of 30 is going to be 1/2. The cosine of 30 is going to be root 3 over 2, and the tan of 30 is 1 over root 3. All right? With the 45, 45, 90, this is nice because sine and cosine are exactly the same. They're 1 over root 2, 1 over root 2. And the tan of 45, well, that's opposite over adjacent, right? And this is my angle. Here's my opposite side. Here's my adjacent side. So the tan of 45 is just 1. For 60, right? So that's right here. Now we're gonna see an interesting thing here. Well, the sine of 60 is root 3 over 2. Sine of 60 is root 3 over 2. So this is root 3 over 2. That's the exact same thing as the cosine of 30, right? This is root 3 over 2. The same thing will happen for cosine 60. So cosine 60 is 1 over 2. Here's our angle, adjacent side, hypotenuse. And the tan of 60, well, what's going on there? Here's 60. Tan is the opposite over the adjacent, so that's just root 3. All right, I don't know why that popped up. Sorry about that. So, yeah, we have these interesting relationships that the sine of x is equal to cosine of 90 minus x with some domain restrictions. Cosine of 60 is equal to sine of 90 minus 60. And the tan of 30 is 1 over the tan of 60. So in other words, the tangent of x is equal to 1 over the tangent of 90 minus x. Okay, let's keep going.